Solving quadratic equations by factorizing. From tutorial 6.4, it is known that a quadratic equation is a second-order equation with one variable that has a general form. We have the following shown on screen. It is called a second-order equation because its variable x is in the second power. On the other hand, with one variable means that only the variable x is unknown, the other letters represent known numbers, where a and b are called coefficients while c is a constant. For example, we have the following shown on screen. Is a quadratic equation where a equals 5, b equals -3 and c equals -2. Solving a quadratic equation means finding the values of the variable x, we call them roots, for which the equation becomes true. For example, x equals 1 is a root solution of the previous equation. We have the following shown on screen. Gives a true result, while x equals 3 is not a root of the same equation. We have the following shown on screen. In tutorial 6.4, we explained just one method for solving quadratic equations, which consists of factorizing the left side of the original equation in the form. We have the following as shown on screen. We have the following as shown on screen. We have the following as shown on screen. Are relations involving new coefficients m, n, p and q to be found mostly by guessing. For this reason, it is not very appropriate trying to solve quadratic equations by this kind of factorization, although here we are going to recall this method again, in order to make it join the rest of the methods explained later on in this tutorial. Example. Find by factorization the roots of the quadratic equation. We have the following shown on screen. Solution. We have a equals 2, b equals -4 and c equals 3. Since we have to express the equation in the form, we have the following shown on screen. We have the following as 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 shown on screen. We, therefore, have the following combinations. We have the following shown on screen. Considering all possible combinations for all four unknowns in the three given equations, we obtain p equals 1, q equals 1, m equals 3 and n equals 1. Therefore, our original equation is factorized as the following shown on screen. Its roots must be such that to make the brackets 0. Thus, the first root is shown in the following on screen. And the second root is shown in the following on screen. Proof. Expanding the last equation yields, we have the following shown on screen. Which is the same as the original equation. As you see, this method is too long and energy-consuming, as it needs to consider many possible combinations until you get the correct solution. Perhaps you have to restart from the beginning when you realize that a certain combination does not result as correct during the way of solution. Another shortcoming of the factorization method consists in the fact that not all coefficients or constants may be integers. Or they may be integers, but none of the combinations meets the description. So far we have considered only quadratic equations which have two distinct roots, but it may occur that the equation has one or no roots, as we are going to see later. Therefore, the factorization method is very limited and not suitable to use in most cases. That is all for lesson 9.5.1. To continue this tutorial, please watch 9.5.2, Special Cases of Quadratic Equations. Thank you for watching. Make sure to like and subscribe to keep up to date with new videos. For more information, calculators, and tutorials, please visit www.icalculator.info.